Hello everyone, welcome to CodeChef. Myself Zalachara and today we are going to solve the problem which came into starters 214. The name of the problem is zero permutation score and the problem code is P5HOME. The difficulty rating of the problem is cakewalk and the prerequisite is at all. Let's start with reading the problem statement over here. So guys, problem says chef has an array A of length n initially A1 equal to A2 equal to A of n equal to 0. Chef wants to transform this array into a permutation of the integers 1 to n. Chef may perform the following operation any number of times. Select an index I such that I lies from 1 to n. Update the value a of I equal to a of I plus 1. After every operation, compute z as follows. Z is the number of indices j such that j lies from 1 to n and both adjacent positions are 0. A of j equal to 0 and a of j plus 1 equal to 0. Chef score is the sum of z over all operations performed. Your task is to determine the minimum possible score Chef can achieve while converting the array into a permutation of 1 to n. Input format. The first line of input contains a single digit t denoting the number of test cases. Each test case consists of a single line. The line contains one integer n, the length of the array. Output format. For each test case, output on a new line, single integer, the minimum score that can be obtained. Constraints for t lies from 1 to 100, for n lies from 1 to 100. So guys, now let's understand the sample test in the question more precisely over here. So guys, this question is straightforward. It says that chef has an array of length n where all the elements are equal to 0 initially, and chef wants to transform this array into a permutation of 1 to n. Okay, so chef may perform the following operation. He can select any index and he can update that index value to a of I plus 1. Okay, so after every operation, we have to compute z as follows. So z is the number of indices j such that j lies from 1 to n and both adjacent are 0. So an indices of an element, basically it's an element where both the adjacent, that is the left and the right, are equal to 0. So that is the z. Okay, so chef score is the sum of all of these z's whose adjacent are 0. So okay, so our task is to determine the minimum possible score chef can achieve while converting the array into a permutation of 1 to n. Okay, now let's take the first test case. Okay, in the first test case, initially a will be equal to 0 and after the first operation it will be 1. So z would be equal to 0. Yeah. Okay, let's take another test case. Okay, let's take the third one. Okay, let's take 4. Okay, so a initially would be like 4 elements for 0 comma 0 comma 0, right? You can see over here. Okay, that is up till a4. And if you apply the operation for first operation on index 2, so a would be equal to 0 comma 1 comma 0 comma 0, right? So we can say that z is equals to 1. This one has 0 and this has 0, right? For all subsequent, if we try, z will be 0. So the summation of z across all the operation will be 1, right? Because everything would be 0. So guys, I think the test cases are pretty much clear. Now let's move toward the simple solution. Before any operations are performed, z would be equal to n minus 1. That is, there are n minus 1 pairs of adjacent zeros, right? So each operation we perform can reduce z by at most 2. If we increment a of I, then only the pairs I minus 1 comma I and this pair, that is I comma I plus 1, will no longer count. All other pairs will remain unchanged. Since we want to minimize the total score, it's clearly optimal to reduce z by 2 in every move we can till it reaches 0. Once it reaches 0, our score will never change. So we can take our time forming a permutation. It's easy to see that z can be always reduced by 2 till it reaches 0 by incrementing positions 2, 4, 6, 8 as our first move. For example, well, where n is equal to 9, the optimal sequence of move is this. And the first move disable pair 1, comma 2 and 2, comma 3. And the second move disables the pair 3, comma 4, 4, comma 5 and so on. So once we reach the end of with the alternating zeros and once we can slowly convert the array into a permutation of say like this 1 to n. Okay, so without ever increasing our score, right? So now that we know what's optimal, let's compute the final score. So we start with z equal to n minus 1 and every move reduced to z by 2 till reaches 0, right? So the overall sum is n minus 3 plus n minus 5 plus n minus 7 plus it so on till it reaches term zeros. Okay, since the problems allows us in O of n, the simplest solution is just to compute this using a loop. Alternately, we can use the fact that it is an arithmetic progression, right? To compute the answer using formula. Okay. So this could be either solving a loop or either we can be an AP problem basically. So guys, I think the solution is very much clear. Now let's move towards the simple C++ code. So guys, this is my simple C++ code. I took the input for all the test cases as well as n. I initialize rem equal to n minus 1 and answer equal to 0. I am doing getting for my for loop, yeah, up till n minus 1, and by stepping by 2, I'm doing my operation, storing my answer into it and printing it. And as you can see that guys, I have got my C++ code right now. Let's move toward the Python code. So guys, this is my simple Python code. I took the input for all the test cases as well as I took the input for n. I initialize a rem and answer equal to n minus 1 and 0. And for I in range 1 comma n comma 2, I will make rem equal to max of 0 comma rem minus 2 and answer plus equal to rem. At the last, simply print answer. And as you can see that guys, I have got my Python code right. So guys, I think the solution, the code and the approach is pretty much clear. Now let's meet in the next video. Thank you so much guys for watching.